Hello guys, welcome to this video. In this video, I am going to be solving Lightning Lab number 1. And the difference between Lightning Lab and a mock exam is the format. So a Lightning Lab is like 30 minutes long, whereas a mock exam is 1 hour long. And in Lightning Lab, you have around 5 questions to solve. Having said that, I've personally found Lightning Labs to be more challenging. And now that our environment is all set up, let's get started. So basically this screen is just the instructions for this mock exam. Let's move on to the next question. Alright, so create a persistent volume called log volume, and it should make use of storage class name manual and should have RWX as the access mode and have 1 gigabit of capacity. Alright, so let's start with the persistent volume. Persistent volume, I'm looking for the definition. And right away, let me search for the term persistent volume. Alright, so as you can see, this is the definition for it. I'm going to copy all the way till storage class name and create a file called pv.yaml, paste it here, and now I will just edit this file to add appropriate changes. Okay, so here first of all we need the name to be log volume. Let's do that. Perfect. The storage was 1 gigabit, so let me change from 5 to 1. Okay, and then read write many, so let's change that to many. And there's no mention of reclaim policy, so let's just delete it, so it will use the default setting. And then the storage class name will be manual. Now we also need to add the path name, right? The volume should use host path, and this is the path, so let's copy that. And then host path, and let's paste it here. So that is it for the persistent volume. And then we also need to add persistent volume claim. Next we need to create PVC called log claim requesting 200 MI of storage. This PVC should bind to log volume. So let's do that. So within the same definition file, I'm going to define the claim also. Let's search for it. Alright, so here it is. Let's copy it until storage class name. Yeah. Paste it here and change everything according to that. So I'm going to start with the name. So the name we want is log claim, and then 200 MI, and read write we have given many for the volume, so let's make this one as well, read write many. And then the storage request will be 200 MI. And this is important. So storage class name should be the same as the one that we have given here, and that's how it will make sure to bind this volume to this claim. So now let's make it manual. Perfect. Now I'll just go ahead and create these, both of the resources. And now if we inspect, we can see that this has been in fact bound to log claim. Perfect. Let's check what's next. Next we need to create a pod called logger at the location where www.engine x mount this in a pod called, okay, so we basically need to mount the claim inside this pod, and this pod should use the image nginx alpine. So I'm going to do what we always do. I'll use the imperative command to first generate the pod file. So the name is logger, image is nginx alpine, restart equal to never, dry run equal to client, YAML logger.yaml. And now let's edit that file. Okay, so here we need to mount that claim also. So let's search for that. Perfect. So this is what we need to do. Okay, on that path. So let me first copy this. Let's go all the way down and remove all of the unnecessary lines. Perfect. And this is where we will paste. The indentation was wrong, so I just removed it. Okay, perfect. And now the claim name is the one that we just gave, log claim. And this name doesn't matter because it's not mentioned in the question, so it just needs to be matched to the mount. So both of these names should be the same. So I'm just going to keep it at that. And then just change the path. So copy this and paste it here. Perfect. So I think this should work. This is enough. create-f logger.yaml. Perfect. Let's move on to the next question. So in this question, we basically we have deployed a new pod called secure pod and a service called secure service. Incoming and outgoing connections to this pod are not working, so troubleshoot why this is happening. Okay, so we need to first troubleshoot. Let's start from there. My guess is there's some kind of network policy in place which is preventing any incoming or outgoing traffic. So let's inspect that. There's something called default deny. Let's check that. Default deny. Okay, so as you can see, when you don't define a pod selector, what it does is by default it will prevent all the incoming traffic to all of the pods. So in the question it also mentions don't delete any current objects that are deployed. So if we would have just deleted this network policy, it would have started the incoming traffic, but we are not allowed to do that. So we will create another network policy to basically override it. Okay, so let's check for the definition. Network policy. And let's copy this whole thing. I just don't want the egress part because we want the incoming traffic. So let me paste it here and Control D. Now let's go ahead and go inside that file, net.yaml. Okay, and okay, so first of all I'll just clean out everything that we don't need. So we don't need the IP block and namespace selectors, we just need the pod selector. So let's go to that line. Okay, remove all of this until pod selector. And also we are just going to define ingress policy, so we don't need the egress here. And at this point I will just confirm all of the labels for the pods that are deployed. So get po, add show labels equal to true. And as you can see, these both are required. So first of all, we are targeting this run secure port. Let's copy that. And the incoming traffic we need to allow from web app color. So copy this as well. Now at the same time, I will also check the service port. So for secure service, it is exposed on port 80. So we need to make sure that we allow traffic on this port. Let's go back to the file. And here I need to change this line where it's role db. And just add secure pod. Okay, perfect. And the second one is role. Instead of that, we want to allow traffic from that web app. So let's add that. Web app color. And the port will be 80. Okay, perfect. Now let's create this network policy. Okay, so at this point, to do the testing, I will first enter the terminal of this pod web app color. And from here, I'm going to make a GET request to this service. So it's on this port. Let's copy that. And the port was 80. So just do that. And as you can see, we got the successful response. So I think we got it right. Let's clear it. Move on to the next question. Okay, create a pod called time check in the namespace dvl 1987, and this pod should run a container called time check that uses busybox image. And then we also need to create a config map. All right, so let's first check if this namespace is already there. I don't see it, so let's create it. And then right off the bat, I'm going to switch my context to this namespace. So config set context current namespace equal to dvl 1987. Okay. Let's first create this config map because we will need to use it in the pod. So the name is time config and from literal. Okay, so create config time config from literal. Okay, perfect. So clear the screen now, and let us first create this pod called time check with the image busybox. Okay, run image equal to busybox, restart equal to never. YAML. Oh, I didn't add the dry run flag. Dry run equal to client YAML, and I'll just name it as busy.yaml. Let's enter this file, busy.yaml. Okay, and here we need to mount this config map. So okay, but before that, I think there's a command that we need to run. So while true do date. Okay, so this whole command, let me just copy it. Okay, so under name, this is where I'm going to add the command. /bin/sh -c and the command. So we have to copy the result of this in the file on this path. So paste that here. Okay, so that is fine, but if you notice there's a $time_frec, and this will come from the config map. So we have to use that config map now, and we have to add the value from the config map as the environment variable. So I'm going to search for that. Okay, so as you can see, this is how we can make use of the environment. Let's copy this whole thing. And then the lines that we don't need, I'm just going to get rid of those. Okay, now here I'm going to add that environment. So the key was time frequency. This is the data that we added in the config map, right? So we need to add that. The name was time config. Remove this line, and the name will be time frequency. Okay, perfect. And then the path OPT time on the pod should mount a volume that lasts the lifetime of this pod. So we need to create a volume. An empty directory volume is the one that lasts the lifetime of the pod. So we are going to look for empty dir. Okay, so this is what we need. Let's copy that. Not here. Okay, so I'm going to add it under command, because if I add it under environment, I'm not sure about the indentation. So alright, the mount path is this OPT time. And then basically I'll have to move this below the environment. Okay, perfect. So let's save this and try. Okay, cool. That is created. Let's go to the next question. So create a new deployment called nginx deploy with one single container nginx and image. Okay, so this is the image we need to create. I'll dry run it. So create deploy nginx deploy image equal to this, dry run client YAML nginx.yaml. Now let's go into that file. And here I need to change the number of replicas to 4. Okay, and the deployment should use a rolling update strategy. Okay, so we are running out of time. We need to really rush at this point. So let me search for rolling update. Okay, so the strategy, under strategy, we need to create a type. So let's go to that. There's a strategy here. type rolling update. Okay, and then we also need to add max search and max unavailable. So that goes under rolling update. Max search 1 and max unavailable is 2. Okay, perfect. So this should be enough. Let's go ahead and deploy it. Create a single final once the okay, but if you remember, we are in a wrong namespace, so let me change that to default one. Set context current namespace space equal to default, and here let's go ahead and create it. Okay, it is deployed now. So the next thing is we need to change the image. Now let me go to kubectl reference, because if you see here, next upgrade the deployment to version 1.17. so let's search for that, and here under set image, this is where it is. So set image deployment, and copy this nginx deploy. Then we need to name the container, so nginx equal to, and then the image should be 1.17. Okay, so it is updated, and to confirm that we have to check the history. So under rollout history, and this is where you can check. As you can see, there are 2 revisions now, and the next step is finally, once all the pods are updated, undo the update and go back to the previous version. So under rollout, again we have undo command. Let's copy that, paste it here, and the name of the deployment is rollback. So we can once again confirm it from the history command, and if you see, there are 3 revisions now. Cool, let's go to the next question. Create a Redis deployment, and name of the deployment should be Redis and Redis Alpine image. It should have exactly 1 replica and request per 0.2 CPU, and with this label. Okay, so let me create that first. Create this. The name is Redis itself. Clear the screen. Okay, create deploy Redis image equal to Redis Alpine, and should have exactly 1 replica. So let's just dry run so we can add the resources. Client o YAML redis.yaml vi redis. Okay, so now request 0.2 CPU. Let's go back to the home real quick. Okay, so this is where we need to add resources. Okay, resources request. So it should go under the pod. Should request 0.2 CPU, and the label should be app Redis. That is already there. So let's go to the image. And okay, so this is where I'm going to add that. Okay. Indentation is very important, guys. Okay, so we don't need to configure memory, and the CPU is 0.2. So let's just do that. Change inside this 0.2. And it should mount exactly 2 volumes. Make sure that the pod is scheduled on master node. So let's schedule it on master node. So under the spec of a pod, we can provide the node name. Master. Okay, so 2 volumes, one for the empty directory and the other one for the config map. We have very less time, guys. Volume. So empty directory, just going to copy this first. And the mount path for the empty directory is /redis master data. Okay. And it should be called data, so change word. And this volume should again come at the same indentation level as the containers. So change the name to data. Okay, perfect. And the config map volume called Redis config, add this one. Okay, config map. So once again, just copy this. Mount path, Redis master, copy this, name, and the name will be Redis config. Perfect, and the volume should be like this. Okay, so let's copy this. So what is it? Just the config report, Redis master. and the name will be Redis config. Okay, so change over config. Okay, and we also need to add the ports. So, it's an array, so container port, and then the container port is 6379. Okay, create f redis.yaml, and I want to make sure that it is getting scheduled on master node. As you can see, it is on master node. So let's go ahead and end the exam now. Confirm end exam. And hopefully all of them are correct. Finally, 100%. So guys, if you enjoyed this video, please provide your feedback. Let me know in the comments what you think about it. And that will really help me with my future videos. Thank you very much.